Howdy folks, welcome back. Thanks for tuning in, and the fun never ends around here. This is a 2006 Yamaha XT225, sometimes known as the Ciro or Cirto, or I think it's Cirio, something like that. Serial, I don't know. Fairly garden variety dual sport, 225 cc's or whatever it accurately is, I don't know, but that's what it says it is. And as you can see, we got no ass end on her, and that's because the swing arm's messed up. And that's because there was no maintenance done on it. And the front brakes were messed up. And that's because there was no maintenance done on it. And so on and so on. I'm going to walk over here and get you the swing arm. Lay it right here so you can look. Swing arm itself is not the problem. It's the dog bone. I'll show you what I'm talking about. The part that goes underneath it and articulates with the monoshock. And those are kind of a feature where, well, you've seen them before, where it kind of transmits the leverage from the swing arm going up and down into a different angle where it forces that kind of in an arc, like in a rotational thing, because there's a pivot right here for this. So the dog bone pivots and it pushes up under a different ratio, not just like if it was directly hooked up to the shock, and therefore it gives it the proper spring rate and the proper compression distance and the whole doodad as far as how this is engineered. Now the pivot for the swing arm is fine, the main pivot. That had some grease in it. The dog bone was another matter, and how I figured this out, or how I found it rather, this thing was all done, and I decided to take the rear wheel off and check the brakes, the rear brakes. They're drum brakes, because the customer had this pulled all the way up on the adjustment and it still wasn't feeling right, so I figured they were worn, and they are. So I went to put it back on because I wasn't going to deal with it at that point. They weren't critically worn. I was just going to let them know that probably next tire change he needs to change them brakes out. And so I'm standing back here, and naturally I'm pulling up on the the nut is on this side for the rear wheel, and the whole swing arm goes clunk, 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 clunk. And I'm like, what the hell's going on with that? So I traced it down to, well, let me show you what I traced it down to. It's in the dog bone, but it's pretty interesting. And I'm going to show you what we're going to do to fix this, because the parts are almost unobtainium. I tell you what, folks, the way things are going with parts in some cases, you should not need a machine shop to replace parts on a 2006 motorcycle, and it's not like it's a rare model. They've been making this model for years and years and years. Anyway, rant over. Here's the dog bone. Okay, so this section here, or this end right here, let me see if we can get you a little bit more light. This end right here, I think goes like this, goes up into this, and this goes into a spot on the actual back of the engine. And it's part of this whole mechanism where it does this. So essentially it kind of does this up and down and pushes the shock. So, you can kind of visualize that. That really doesn't matter. What matters is there was a huge amount of play, huge, in this these pivots. I would call them bushings and pins, because that's what they are. And so, well, I'll show you that in a minute. But the main problem was, and it goes this way because this goes up to the shock, this side, is down here on this section that goes in here, there is a pin and two bushings, and they're the smaller of the two bushings. You can see, I'll give you two examples here. This is one of the big ones. This goes here. This is the main pivot. Disregard this for a minute. I'll explain this in a minute. And these bushings go here, and then this bushing goes here. Now I say bushing singular because although it calls for two, one here and one there, there was only this one in here. That's it. There's no evidence of pieces of it. There's no evidence of where it might have gone. There's actually two little grease seals that go on the outside here, so it would have been kind of captured if it was in fragments. Nothing. So I have to assume that Yamaha never put two of these in from the get-go. Luckily it didn't take out the bore, but it did take out the pin pretty good, and this bushing was pretty bad as well. This is where most of the play was coming from. What this essentially was doing was, under load, it was doing this. It was cocking. And that started to take this one out, and I'm lucky it didn't take this one out where it goes into the shock. So this whole thing was like giving, twisting. It just, mainly this part right here, and it just wasn't right. So it took me a while to figure all this out, and so I said, well, I'll just order new bushings and maybe a couple pins and we'll be done with it. Naturally, I go online and try to buy the parts, and I'm thinking that the website actually was laughing at me. Some of this stuff, like pivots and the bushings themselves, both, I think one of the pivots they had in stock, I don't remember which, but both of these sets of bushings are about as rare as an honest politician. I forgot which one. I forgot if it's this big one or the smaller one right here. I can't remember which. I got to go look at the parts order. Is keeps getting pushed back. Um, uh, Updates from the manufacturer that it's going to be delayed. So it's going to be a while before I got these. So I said, you know what? These are kind of crappy anyway. I'm going to go ahead and make new bushings for it. Now, what they used, and I've had to do a little research on this, is these are actually ferrous, so a magnet hits them and sticks. But apparently they use some sort of a copper coating, probably on both the inside and outside. But the inside has got, I think they said it's like a nylon or some sort of a coating like that. It's not a ceramic coating at all. It's definitely a softer plasticky coating. All right, so that's what they used on those as a material to go between the pin and the bushing, like so. All right. Now, I think I can do better than that. So the question I have is, am I smarter than a Yamaha engineer? We're going to find out in this video, because what we're going to do is we're going to make some new bushings, as I said, and I have a proof of concept. This is the one I said disregard before. Let's go ahead and regard this. This is a piece of oil light that I got over at the hardware store. It's 1-inch OD and I think 3/4 inch ID. Yeah. And it was bigger than the bore and smaller than the pin. So I was able to turn it down and bore it out, and there was a proof of concept. Now you might say, well, let's just use that. Well, the problem is I don't have any that will fit this one. I can make one by like making a composite bushing by pressing this into that and then turning and then boring, but I don't want to do that. And plus, this oil light, or these hardware store oil impregnated bushings, they are a prick to machine. They don't machine well at all, and you got to use a super sharp tool. I looked online. They recommend like carbide for these things, actually, because the sharper the tool, the more porosity, what an ass, the more porosity remains, and that's how the oil leaches out and acts as a self-lubricating bushing. We don't really need a self-lubricating bushing because this has got grease fitting, and these are going to be greased, hopefully, if the customer actually does some maintenance in the future, which was not the case before. So I ordered some, I think it's 525 or 545 something bronze from McMaster Car, which is going to be here today, 1-inch diameter. And what we're going to do is we're going to cut it off in workable pieces to make 2 of these and to make 2 of these. So that's what we're going to do in this video. I'm not going to show you the machining on all of them, probably just maybe 1 or 2 of them, depending on how interesting it looks, because it's going to throw bronze chips everywhere and make a big mess. But that it's a, whatever the grade was I chose, it's a machinable and strong bushing grade bronze, according to the McMaster site where I purchased it from. We're going to find out if I'm smarter than a Yamaha engineer. So place your bets. This is the larger of the two. That's what we're going to do now. And you can see the dimensions in imperial. So pretty simple. Length, width, and bore. What I found from doing this proof of concept is you essentially make these exactly the sizes on here, which are measured up to the exact size of these bores. And, you know, the same size can't fit into the same space without being pushed, and it's just enough of a fit as far as a press goes to be a pretty much perfect fit. The exception, of course, is the bore has to be bored out about 1/1000th more, because that's going to kind of push in circumferentially, there's another word for the day, to reduce the size of that bore, and that's what I did on this one. when I did it. I actually made two of them. I just didn't put the other one in. And they both came out the same, and I'm sure they would work the same. The overall OD is 907 thousandths, so there's not going to be too much taken off the OD since this is 1 inch. That's about 93 thou. It's going to come off on the OD. But the ID is going to have to be bored out significantly because, the walls on that are not very thick. What we're going to do first is face it off. And as Quinn would say on Blinding Hacks, as is tradition, what I'm going to do now is I'm going to do the outside and leave about, 10 thou or so. And then I'll start on the inside. And then what I'll do at that point is I'll just finish everything up in the other final operations. 20 thou, let's see how it works. Not bad, but I think I'm going to go a little bit faster. Try that. These old lathes are a pain in the ass, but they're fun nonetheless. Making stuff is fun. That was 20 thou. Let's just do 10 more. That's a lot better. Of course, it's a light pass, so we'll see where we're at now, and I'm going to have to mark that. As far as length goes, it's not critical. If these are a little bit longer, a little bit shorter, it's not a big deal. Because there is some space between the two of them for grease, the whole grease. 1.046. So if I went 100 thousandths, it would be 946. And we want to go to 907, so we'll start with that. We'll do 100 off of it. Now in this lathe, the dial here is not actual as far as what you're taking off. It's per side. So when you dial in 10 thou, you're taking 20. So it's actually moving this in, 10 thou. Not 10 thou or 5 thousandths on the side to give you 10 total. So some of these lathes, you have to keep that in mind. Because especially these cheaper ones, hobby lathes, it's just something to keep in mind. But it is very accurate. When I dial in exactly 20 thou, it takes off 20 thou, so it's actually pretty good. So we're going to get our 100 thou taken off. I'm going to try 40 and see what happens. Yeah, a little bit of chatter, let it go. Alright, so we're at 970 right now. It's 100 thou. It's just like I predicted. Like I said, it's relatively accurate. It really is. Pretty close. And I'm not going to worry about a little chatter right now. Now, I could put the live center in there, put a center in it, but, it's not a big deal because we're going to be finishing this thing up with very light cuts when we get to that point, so I'm not going to worry about it. So we're at 970. She's hotter than a $2 pistol. So look at that. I mean, 1 thou off. And that's with a heavy cut and thing chattering a little bit, so that's all right. So we're going to dial up about 10. So this is 10 thousandths. See how it deals with that. Got another phone call in the middle of that. My phone has been absolutely ringing off the hook. There ain't no hook. It's been ringing. And I'm getting too much chatter on that, so I'm going to slow it down and try that. It's only a 10 thou cut. It really shouldn't be doing that. I may have to regrind this tool. It's probably the angle that I'm at. I'm too close to that relief, and that's the problem. But let's give it a shot. Alright, we're going to have to figure this out because I'm still getting some chatter in there. I just don't know why. But we'll figure it out. I'm not too terribly familiar with this metal. I may have to just cut some more, grind some more relief off the backside of that tool. But that's close enough for now. Should be at 920. 930. It's even better. Fine. Alright. And so now we'll go ahead and drill it, and then we'll work on that inside part. And I'll fix this. It'll be fine. I went ahead and reground that tool geometry, whoops, because I didn't have enough positive rake. Trying to keep it low because I use this on brass too, but I needed more on this. Now I'm at 918, so I'm going to leave it there, so about 10 over. That's perfect. But I got a nice finish out of this now, so that feels good. So I'm going to be happy with that. Alright, now let's move on and we'll do the inside part. I need some new center drills. That ain't going good. Oh, nice! There we go. Try one that actually is not dull. Shit can't be that hard. Said the wife. Here's a 13 millimeter twist drill, brand spanking new. Let's try that. Not try that. God dang it. There we go. So I'm just going to use the boring tool rather than try to put a bigger drill in. I mean, this is much less tool load and it's much more efficient. As you can see, these little lathes are not terribly happy when you're running a drill even a ½ inch through stuff. I make mistakes, so you don't have to. I'm going to try about 15 thou first, see how it likes it. 5 1/4, 525. We got to go to 787. Hang on, let me think about this. I'd really like to get this ID done for both of these in this operation. That would really be the safest play. But we're going to have to go up pretty deep. I don't know if we can do it with this. I can extend this out into the tool holder a little bit, but still. I don't know. We're going to figure it out. You know what? I think we can just get there. We had a Dave Matthews Band moment there crash into me because there wasn't enough room. So I did have to grind some relief back. So let's go ahead and do a boring interlude set to some interesting music. I'm at, what was it, 779, I think. So I got to go to 787. So that's good for a final, couple of really quick cuts. But it's hotter than a $2 pistol. So what ultimately has to happen is this pin needs to fit in there. So what I'm going to do is I am going to take it to the limit one more time. And we'll get it to fit right. And then finish the outside. But let's let it cool off first. The dog needs to eat, and I'm going to get a drink of water, and then we'll come back and we'll finish this out. You ever have this kombucha? Kombucha, whatever the hell it is. Pretty good stuff. Here's to you, milling machine. She was hot. I did a spring cut after that last one. Did I mention I did a spring cut? And that way I know exactly where I'm going to be here. Let's see where we're at. 7. I'll show you here in a sec. I know it's upside down, sort of. 7, 75, 79. Yeah, exact. 79 and a skosh. So pretty good with those dial calipers. Yeah, 775, 679. So we're right where we think we are at. But we're going to finish her out now. And for the outside, we'll just take this and try to shove it on. Shove it. And when it just starts to want to go in, after we knock the edge off, then I know that that's going to be ready as well. Alright, so let's see. What do I want to do? Probably, let's just go 5. Now remember, same deal. When you're doing 5 thou, it'll be 2.5 on the indicator, not 5. If you do 5, it's 10. 1, 2.5. But we're going to sneak up on it. Again, this pin is a little bit of wear, but only in a couple spots, so it's going to be a good guide. And we can just get her in with just a tiny bit of movement. So it's really just a slip fit now. That's about it. Right there. Goes in and a little bit of play. That feels good. Yeah, I'm not going to measure it because I know that's going to work because, like I said, it worked on the other one. I know it's slightly different material, but it is what it is. So now we finish up this outside to dimension, and again, I can put the dog bone up here to make sure that that is right. I'll do that off camera, bring it back when that's ready. Yeah, so we're still big. See what I mean? Doesn't even want to really try. So what we'll do is go down a thou at a time, and then I'll bring you back when she's ready to go. Well, I actually went a little too far. It shouldn't be this easy. It's an absolute slip fit. There's no play in it whatsoever. And that's okay because we can use something like, I can just use some sleeve retainer and put it in with, and it'll stay. Because this thing is actually a really, really tight fit. Tighter than I normally would if I was pressing it. So it's going to work out okay. I'm not going to worry about it. I'm pretty sure, though, the way these things were pressed in, that they're designed to be, with that nylon or that coating, whatever it is. They're designed to be a pretty firm fit on these things, but I can't tell you for sure because I don't have any new ones. They're not available, as I said. At least 2 of them aren't. So, yeah, I went a little too far, but that's all right. It'll work. I'm not going to scrap it, and just do better on the next one. But sleeve retainer works fine on stuff like this, and but the finish came out great. I took another thou and it was just too much. Thought it was further away. Oh well, happens. So basically at this point, I'm going to part them off to length. Now I'm going to go ahead and do that off camera. I'll get them installed in the dog bone. I'll show you how it looks finished up. Okay, let's see how we did. They did actually press in just a little bit, but like I showed you, it's pretty much one of them at least is an exact fit. So little sleeve retainer, and voila. Now right there, I mean it has just a tiny bit of movement. You got to have some clearance in here. I mean, even the ones that are, where those things go, even the ones that are nylon coated, whatever the hell that shit is, it can't be that tight because it takes grease. There is a grease fitting here, which is why you do these in halves. As you can see inside there, there has to be a cavity for grease to sit. So otherwise I would have made one big long one. But that would have been impractical and impossible in this case. So, let me show you. Let me hold it as still as possible. I mean, we got barely any movement there. So I think it's going to work fine. Yeah, I went a little bit aggressive on the ODs. But I'll tell you right now, that sleeve retainer is going to hold these just fine. I use it on a lot of different stuff that are slip fits that I don't want to move. I don't want them to move. I'm going to polish up these bores by hand a little bit. I got a couple of tool marks I don't like in there. Other than that, it looks crappy, but it actually is pretty smooth the way it is. Yeah, it's just from chip buildup and stuff in there. It's pretty smooth. So yeah, I'm okay with it. I think it's going to work just fine for this, and tighten this all up, and then we'll do the other one another day. This one will be easier because it's smaller. I did this one first because you have to take off more material. On this one we have to take off more in the OD, but not so much on the ID. So yeah, I'm okay with it. And I gotta be honest with you, I really think that this material is going to be a hell of a lot better than these things, whatever the hell they are. I don't know. I don't like that coating in there, and these things just, they wear out. When they're not greased all the way, they wear out pretty fast. Now this bronze is going to do a number to these pins if that isn't done as well in the future, but either way they're going to wear if they're not maintained. But I think this is going to be stronger, longer lasting in the long run. See, that's perfect. I don't have any movement at all, barely. And I don't know if it answers the question of whether I'm smarter than a Yamaha Engineer or not. Probably not. I think I'm a little more crafty. Well, here we are where we started. This is the end. I think it's going to work fine, as I said about a dozen times before. And we'll do the other one another time. You won't see that. You've already seen this one. Why would you need to see that? So speaking of see, if you want to see more of this junk that I'm putting up on the channel, there's 3 things you need to do. Subscribe, ring the bell on the channel to get notified, and like the video. All 3 of them help me. And I can help you by doing more of this stuff. May or may not be smarter than an engineer. Who knows? I guess time will tell. Till next time, speaking of time, thanks for watching. Don't just repair, restore. Catch you on the next video.